Hey everybody, it's just a test video to see whether or not I actually have the ability to make a video for our classwork over the next couple weeks. So I'm just going to go through an example or two from the work we had for class. Also, heads up, if you hear anybody in the background, that would be my kids. Alright, so number 8 was asking if you have a neutral atom, which particles need to have equal. If something is neutral, that means it has a charge of 0. So neutral equals charge 0. And it's neutral, so the charge has to be balanced in order for that to happen. And the particles that we have are protons, which are positive, neutrons, which are neutral, and electrons. That's my cat, by the way. Everybody say hi to Zoe. So if it's neutral, that means you have to have the same amount of the parts that you need to get to a charge of 0. So it doesn't matter how many neutrons you have because their charge is always 0. You could have 0 or you could have 100 and your charge will still be 0 because of those. If you have protons or electrons though, they're going to add charges. So to make sure it's 0, you need to have the same amount of positive and negative charge. So if it's a neutral atom, the two parts that need to be equal are protons and electrons. And then for 9, it asks how many protons and neutrons are in the following particles. You have two parts in those symbols there. On the top left, you have mass number. And mass number is the total mass, meaning all of the protons and neutrons combined. Then you have the symbol. That's the atomic symbol. And then underneath the mass number, you have the number of protons or atomic number. Atomic number is the same as the number of protons. And mass is the same as the number of protons plus neutrons. Okay, so if we have 1 over 0, and n, it's lowercase, so it's not an element if it's lowercase by itself. Atomic number is 0. If its atomic number is 0, that means you have no protons. So 0 protons. And if its mass is 1, that means the number of protons plus neutrons has to be 1. But it doesn't have any protons. So if it has 1 proton plus neutron, and it has 0 protons, that means it's 1 neutron. And that's why it's a lowercase n. It's telling you it's a neutron. So 1 neutron. Next example is 1 over 1. So 1 over 1, uppercase H. Uppercase H is hydrogen. And if you look at the atomic number there on the bottom left, it says that it's 1. If its atomic number is 1, it means it has 1 proton. And its mass is 1 also, which means that the proton is the only thing giving it mass. So that's 1 proton, 0 neutrons. Next one up is the same element as before. It's hydrogen, but it's got 2 over 1. So that was, first one was A, second was B. Now we're at C. 2 over 1 hydrogen. So I'm going to separate these. So that would mean that we have a mass of 2. So mass number is the top one here. So it's 2. That means there are 2 total protons and neutrons when combined. Mass number is 2. We have 1 proton. So if the mass is 2 and there's 1 proton, that means you have 1 proton plus 1 neutron. So you've got 1 of each. And the last one, that is what's called an alpha particle, also known as helium. And it has a mass of 4 and an atomic number of 2. So this is D, and the last one. Just make sure it's actually still looking at the paper. Can we see the paper? Yeah, I can see the paper. Okay. So for that last one there, we have 4 for mass, 2 for atomic number, and helium's symbol, He, tells us the element. And we're trying to find out the number of protons and neutrons. Its mass is 4, so that means the total between protons and neutrons is 4. And we have 2 protons. So if you have 2 protons, those 2 are the same. And neutrons has to be 2, because 2 plus a number has to give us the 4. And there are 2 protons because the atomic number is 2. So we have 2 protons and 2 neutrons.